residential, industrial, commercial.
Define, design, refine. Architects World. Delving into the field of design. Opening the mind to possibilities. Highlighting opportunities for everyday living. Architects World. Tuesdays 2 p.m. to 3 p.m. on 92.3 Nigeria Info.
Good afternoon. Welcome to Architects World on Nigeria Info FM. We get to talk the world of design, really, from buildings, constructions, designs, sustainability, all there is to in the world of design. That's obviously what we focus on the show. I'm Gabriella. 8 minutes gone past 2. I never do this alone. I'm always joined by architect Bozimo. Good afternoon to you. Thank you so much for joining me this week.
Hi, good afternoon, Gabriella. Great to be here.
All right, so today on the show, you will have the chance to be a part of the conversation. We'll open the phone lines in a minute. Today, we're going to be talking design principles for wet climates. I mean, it's quite relevant because that's the season we're in right now, with consistent rains for the past few days in River State. Obviously, I'm curious to know, how we can better structure our buildings for a season such as this.
Indeed. You'll find that in this area, for the past 3 or 4 days, we haven't actually seen the sun. Fortunately, today it's begun coming out a bit, and I think it's going to at least give us some relief and cheer up the area. Yeah. And the same thing has been for most of the last week. The rains have been heavy, they come torrentially. There's this quick burst that often leads to flooding outside, even if it disappears or dissipates later on. It causes problems. And in many people's cases, when they forget to close their windows and the rain starts, they remember either their bedside is going to be wet or close the left outside. So there are certain things we can do to enhance our ability to live with, because the rains are our friend if we properly integrate them into our built environment. Of course, at the level of community, you want to try and make the community more resilient. So when those floods come, and flash floods that we've been warned against, you want to have a place or a way for the water to gather sometimes and then eventually dissipate. So you have to also, there are some principles where in some community they say, look, when the rains are this heavy, there's some areas that we're just going to cede to the water. And so everybody kind of retreats from those areas. These are different principles in urban design and urban planning. But now, narrowing it down to the individual project site or actual building or complex, there are certain things you're trying to avoid. Water is nice. It's life. But when it comes in the wrong way or falls on the wrong surfaces, then you're going to have a problem with it. Now, in our built environment, where does water most come from? The rain. But we also require some water inside our buildings in terms of water for washing and other cooking, water for flushing, and also conveying waste. So we also let or install water into our buildings. And what we're trying to do in all situations is control what the water does. We want to make sure that it is not intruding where it's not wanted. And we also want to ensure that in the areas where it actually does come in, it is not staying longer than expected. And I'll give you an example of such areas. A nice tropical design would have a terrace, a balcony where you can sit. That is likely to be an external, so in an external area. And you do want your area open to the air and all that, but when rain falls, it may tend to come in. So what you want to ensure that even when rain does come, very quickly that water can go out. So it's important there that you incorporate things like drain holes or weep holes, so that the water follows gravity all the time. That's one of the simplest things about dealing with water. Once you can make water follow gravity, it will go. But all too often you find in some situations people have not put sufficient slopes and water gathers. Water is not destructive until it's sitting for a long time on a certain surface. Then water, as we know, no get enemy. It will find its way to permeate that surface. And it can lead to things like your ceramic tiles popping up over time because it's melting or dissolving the adhesive. And when it goes below that, maybe into your concrete, it can start to cause rust of your reinforcement if it's on a suspended slab. Those are things that are messing with the structural integrity of your building you never want. So, top of mind, top of the building, the roof. We have different things we're trying to achieve with roofs. One, often, is aesthetic. Your roof is fairly prominent. It's going to be most likely the first thing somebody may see when they're approaching your structure. And so people like to have, a bit of design elements on your roof. That's fine. Once you have achieved between 2 and 10 degrees of slope, water will run off. So we have some very interesting roofs coming up in every city in Nigeria where the slope of the roof is about 60 degrees upward. That, I think, is taken from buildings that people are trying to model after, built like in the Swiss Alps.
Okay.
And when people are building for that kind of place, they are considering what can happen when snow falls. And snow can fall very fast, up to 3 or 4 or 5 feet in an hour. That becomes very heavy. So when you have buildings like that, you have very steep slopes to ensure that the snow never has a chance to accumulate on top of the building and add too much dead load. But here, in this part of the world, it's really only water. And water does not accumulate. So sometimes you see these roofs that are literally as tall as the floors of the building or even taller. And even if you're going to do that, over there, they tend to utilize that additional roof space in terms of an accessible attic. So they add useful living or sleeping space. Here, we just seem to put it with lots of wood. It's very expensive and is really doing very little in terms of adding to the ability for your roof to shed water. But that's fine. If people feel they can afford that, that's very okay with them. I just say, once you've achieved 5, 10, 30 degrees at most, you've got what you need to make sure water falls up. But that roof could also have some penetrations. You could have some services that come through the roof. You have to be very careful with how you deal with penetrations. Any surface that is exposed to the outside world of your building is a potential place where leaks can occur. And the detailing of those spaces, of those locations where two dissimilar materials meet, is critical to how well that building or that building envelope will perform regarding water control. And that is where you must rely on your professionals who will take assorted things into consideration. Some roofing materials side by side with some other roofing materials have different coefficient of expansion. So when the heat is affecting one material, it may begin to swell differently from another. How those materials sit side by side can affect very much whether or not water will penetrate your building. Another place that's very easy, where I found it happening wrong, is external windows. The windows look all right until rain is being forced against the glass by, rain by breeze. Then you find that water that normally should just fall down is being pushed through the window frame and eventually is finding its way into the building. Some people have this experience, especially in this rainy season. They come back home and the door, just inside their door, there's a bit of water. That's because the rain has been falling, the wind has pushed it, and it's found its way under the door. There's supposed to be a threshold. A threshold is supposed to prevent water from being able to force its way underneath your door into your house. The thing about these is that they can be very dangerous. If you're not aware, you can step on that kind of moist surface unexpectedly, slip, trip, or fall, which could lead to injury. Also, when you have a building that has moisture just lurking inside, you are really reducing the indoor air quality. And so you enter the space, it smells damp. You know, our noses are very sensitive. You may not be able to sense water to the touch, but you're just aware that there's this humidity and clawing in the air. And a lot of the principles of design have to do with minimizing or indeed eliminating that lingering humidity. Of course, the architectural design should provide, where possible, for adequate ventilation. But even if you're in a building that is not relying solely on ventilation, the air conditioning systems, which are designed by the mechanical engineers, will also incorporate elements of cooling as well as dehumidifying. And that too is not something you just point at an AC in a store and say, bring me 6 of these. There are specifications. They may all look alike, but it's the engineer who knows what different qualities may be utilized best in a given space.
Fantastic. Now, while you were speaking, I was thinking about, my mind just went back to a couple of years ago when I was in school. At the time, I was living in my aunt's house, and I can relate with that humidity you spoke about. You know, you just come into a room and it's just moist. You can't see any water. You can't feel, sometimes you can't even feel it, but you just sense that, you know, and it's really uncomfortable. How can, you know, people avoid that happening with their buildings?
You see, right from that design stage, the considerations are many. A room is a room is a room, but how well it functions depends very much on the amount of design theory and thought that goes into it. I always say that we're so familiar with buildings, especially with buildings that work, that we often forget what it takes to make sure that a building functions as intended. So the key things you are trying to do to control water, first of all, you're trying to avoid it entering at all. You're trying to make sure that your building external envelope is watertight. You're trying to ensure that even when water falls, because rain is blasted against your wall, that the water is not retained for long enough to start seeping its way through the wall through capillary action. Also on the exterior, you want to always make sure that when water does fall outside your building, it drains away, because one of the biggest problems many people, wall is painted this year, by next, in some cases on tension, there's nowhere else for it to flow along, so it falls. There's some very fantastic stores in this city right now that since the rainy season came, they've started looking very nasty because all the beautiful paint has started coming off. And you would think that somebody who's investing that much in their brand name stores would invest in the knowledge to ensure that they have minimal maintenance costs, because this thing is much more than only the health and welfare of the people inside, which is paramount. It's also about minimizing maintenance. You don't want a building that you paint and within 3 years, if you don't paint again, your brand is being diminished. You are looking decrepit and dilapidated. By design, you want to make sure there are overhangs. You want to choose the right types of materials for wet climates that will not allow water be retained for much longer. You might choose certain materials because they're part of your brand, but be careful how you place them. You may not decide to place them all over the place so that the areas where the challenge can arise are minimized. You also want to break the transition of water from outside to inside. An example, the windows we're talking about, there are rubber seals that should be within the construction where you have the metal frame and the glass. You always want to have some rubber seals. One, they keep the windows quiet from rattling, clack, 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 when wind is pushing, because buildings are actually interfering with breeze. So in your design, you're always thinking that it's not just the weight of the building, but things like breeze could typically, if you were exaggerated, you could knock the building over. Places like windows and doors are some of the places of least resistance. So you want to have your rubber seals around all the glass panes. What that does is that when water attempts to come through, the rubber repels it. You will have little or no water coming through on a window that's otherwise looking sealed. And what that tells you too is if water can come in, it means any air conditioning you're putting in on the inside is actually trying to cool the whole outside, because it's pulling in the external air. So you're not actually getting the maximum efficiency you should get. In the doors as well, you want to make sure that the doors are properly sized, positioned, and sealed, so that external winds and all that can't come in. That goes hand in hand with at the time when you do want to ventilate the space, because air gets stale just by us breathing in and out. By the time people are cooking, all sorts of things, air begins to feel stale. If a building were perfectly hermetically sealed, it might not be comfortable for very long. So you want to have a minimum number of air exchanges per hour. When you do want to ventilate the building, you should be able to open it, and the air should flow very freely for, the time frame you have in mind, so that you refresh the scent and the sense of well-being inside the building. Of course, you improve indoor air quality. So there are a number of things you would always be looking out for. The dampness leads to respiratory illnesses. Have you ever been in a house where somebody just has a cough that doesn't go? You do the cough syrup thing, you do all the other things, but the cough doesn't go away. If you investigate closely, that building could be suffering from sick building syndrome in its own way.
Wow.
And sick building syndrome is a real thing. When you have damp that rises, there are these mold spores that are released into the air. Of course, they're invisible, but they get into our respiratory system, and sometimes adults may be more resistant to them, but children especially can suffer very badly, and at an early stage you don't want that. Another thing is that these damp conditions are magnets for bacteria, damp, mold, termites, ants, because they can find habitat that works for them whenever there's damp in a corner somewhere. So you always want to make sure that your building materials are properly chosen, properly installed. Some of the worst building collapses, this is on a separate level, have happened not because the materials that were selected and installed were not the right materials, but because they were not installed properly. The same thing happens with your windows and doors. A window has a front and a back side, i.e. a side that's supposed to face the outside and a side supposed to face the inside. If you install them the wrong way, the window will not be acting properly for you. The same thing goes for doors, same thing goes for everything. You're supposed to assemble your building properly according to the specifications that were chosen and according to the manufacturer's details. Now, the people who have those manufacturer's details closest in hand are your consultants in the various spheres. Your air conditioning, typically, if it's split like this, there's a hole in the wall somewhere where the pipe for condensate to drain out went through the wall. That is one of the holes that must be carefully considered, so that it's large enough to let the pipes go out, but not so large that it's a rat entrance, and also not so large that water can find its way in. So even where it's placed on the exterior should be considered carefully, so that you minimize, how much wind can come. And I've mentioned to you before that when you're designing a project, you're looking at the whole project in context of the climate, what affects it, where are the primary winds coming from, and those are things that an architect and the other consultants take into consideration when locating things like windows, entrances, doors, canopies. There can be a building whose entrances face a certain place, and you can avoid maybe using a canopy, but based on the geography of a certain other building, it might be inevitable that you must expend the money to do a canopy to avoid slanting rain from hitting your door directly. I'm sure you've driven past some buildings where the upper part of the door still looks good, but the lower part has faded. That's because that lower part was unfortunately being assaulted regularly by harsh weather. These are things that can be avoided with proper design considerations.
No, I was just looking at the screen while you were speaking a while ago. I'm sure you must have heard of what happened in, I think it's Louisiana in America, the hurricane.
Louisiana, the recent one.
I was seeing a video that was shown just a while ago. I was seeing so many houses that were submerged in water.
People, up to the door lintel level.
And it's really sickening that in Nigeria as well, we're beginning to have, maybe not at the hurricane level, but beginning to have same experiences. Look at what happened in Aba, for instance. That must have been
I saw
over
that
the weekend,
just a couple 3 days ago.
A couple of days ago, people were literally submerged in water
up to their waist, shoulders.
I saw some women who were carrying, property, things, goods on their heads, and literally their entire bodies were in water.
I saw that.
Now imagine the impacts of that on our building. So my question right now is, can we actually, if we obviously consider these things that you've mentioned so far, is it enough to help a building withstand, should there be a case of such heavy flooding as witnessed in Aba, for instance, or some other kind of flooding like happened in America? Can holding these considerations help a building withstand the impact of such rains?
Now, from a global perspective, I will tell you that Aba is going to become much more common everywhere because climate change is happening and is very, very real. Now, one of the most valuable professionals in the built environment regarding that is your land surveyor. They are the people who can help set the benchmark heights for what is called the 50-year flood level and the 100-year flood level. The 100-year flood level is considered to be the worst anticipated level to which water will rise. And you can decide that, look, you're going to design your building so that the lowest level actually is above that level. Sometimes it might look a bit preposterous because the building looks very high. But this goes back to some of the methods I was talking about that are being used in some urban design solutions. They might put certain spaces that are not as critical on the lowest levels, knowing that, look, this building has already stood here for 40, 50, 100 years. Yeah. We can't dig the ground underneath it and raise it up. They might convert it so that crucial elements of the project are elevated. Things like power generators may no longer be on the ground like we typically have them, but may be elevated so that in the worst circumstances, they can still work, especially maybe in somewhere like a hospital that's critical. Yeah. You also want to ensure that you can cut out some of those areas. So what happens when that kind of terrible flooding happens is that people they cede the lowest levels of the building. They accept that those levels cannot be defended, and they retreat upward. You see, this is a practical solution that's emerging now because the world's climate, those floods you saw, the hurricanes, I happen to have been there right after Hurricane Katrina many years ago in that same Louisiana. There were buildings where the water was above the door height. And on each of the buildings, you just see a diamond where they will put how many people were found alive, how many people were found dead, just on each of the buildings along the street. You'll see a water line taller than myself, like a bathroom water line, along the entire neighborhood. So Louisiana is a unique place because it's really very, very low lying. But Lagos has similar things. Some parts of rivers certainly have a delta, all these Bayelsa and Co. Yeah. We have to proactively, there's some buildings already built there. We have to become practical and pragmatic and understand that there is going to be a measure of ceding territory to nature. But going forward now, we can begin to think of better ways, solutions that can at least allow nature, intersperse with us. There are some situations where you must create water walls and dams and other things like that. And there's some solutions that actually will come up inside your doorway to prevent water from entering. But to what extent those might work is up for debate. And for how long can those barriers withstand? Because, okay, you might stop the water from entering your door, but if the water is just lapping on the outside of your wall, after a while it might start seeping in through your walls. There's one other thing, at least to fight rising damp, in terms of construction, sequence, materials, and placement. There's something people don't do. It's called the damp-proof membrane. When building in an area like this, any area that's wet, after you've come up in the substructure, you have to separate the water that can creep up your substructure from the water that can now creep up the superstructure. The superstructure are the walls above ground, substructure are the walls below. There is something called a damp-proof membrane, which has to be placed underneath the ground floor slab before you start pouring the ground floor slab. People don't do it. It could be, it's like tough tarpaulin or tough polythene. You put it there, and then you do your slab on top. What happens is that water is very, very insidious. It will go, it'll either drip till it finds the hole, or it will creep upwards. Exactly. But when it comes to that barrier, the damp-proof membrane, it is stopped from climbing, and that is the best way to stop water from rising. Wow. Many buildings don't have it. That's why you find those conditions happening. Now, there are some commercial solutions for buildings that have it, and they involve people going, digging holes in the bottom of the wall, pumping foam in and all that. How well those work could also be up to debate, and it would depend individually on the circumstances a particular project finds itself.
All right, we'll take a very quick break now. Quite interesting conversation. We're talking about design principles for wet climates, and we'd like that you join the conversation and share your thoughts, whatever questions that you might have or comments you obviously can share. We'll take a quick break, and when we return, the phone lines will be open and the conversation continues.
To thrive in a fast-changing world.
Tune in to 92.3 Nigeria Info for the best of news, talk and sports 24/7. Our freedom depends on our proactive responsibilities.
Let's talk, act, and be about development.
With one voice, our potential is realized. This is your number one news, talk, and sports radio station. 92.3 Nigeria Info. I am listening.
Structure,
lease,
construction,
edifice,
infrastructure,
masterpiece,
residential, industrial, commercial.
Define, design, refine. Architect's World. Delving into the field of design. Opening the mind to possibilities. Highlighting opportunities for everyday living. Architect's World. Tuesdays 2 p.m. to 3 p.m. on 92.3 Nigeria Info.
Welcome back to Architect's World at 92.3 Nigeria Info. 23 minutes on the clock. We have barely about 10 minutes, I think. Oh, less than that, actually. We have about 6 minutes or so left for the conversation. We'll have to wrap up earlier than we normally would at 3 o'clock because there's some information at 2:45 p.m. for you. So we'll get to it right now. The phone lines are open. Whatever questions you have, you can call in and share. 0817-923-0002, 0817-923-0003. You can also call 0817-923-0007 or 0817 923-0009. The WhatsApp number is 0809-030-6416. The conversation still is about design principles for wet climate. So, over to you, Architect Bozimo.
What I'll tell you is this. The water is a very persistent, feature in nature. And funny enough, what it takes to handle it, because I don't believe you can fight water successfully. I think you just have to understand it and then navigate and in fact incorporate when you can. So the solution is in the details. You have to understand how it works, how to drain it, how to control it, capture it properly. Because otherwise, you run that risk of just creating unnecessary barriers that water will surely breach. So one of the first things we try to do, you try to see whether you can incorporate gutters and downspouts. So when the water runs off your roof, it shouldn't necessarily, unless that's your choice, fall straight to the ground. Where possible, you can gather it in roof gutters along the edges, and then those are properly brought down to the ground level. And that way, you are the one deciding how the water around your building works. Another thing is ensuring that you have proper slopes on your roof, proper slopes around the building on the outside, proper slopes even on your window sills. Your window sills shouldn't be perfectly horizontal. It should be slightly inclined outward so that when water does fall, it finds its way out. You also want to make sure that whenever you have dissimilar materials, you want to have flashing. Flashing is a metallic piece that you put wherever one roof may be meeting maybe a wall, to ensure that when the water is falling down along the wall, it doesn't just find its way in that amazing way that water has to find its way into your building. You're always trying to make sure that you're keeping it out.
All right, let's quickly speak to Kella. Kella is on the line. Oh dear, sadly lost Kella's call. Ida from Ankara. Good afternoon.
Yeah, good afternoon.
Good afternoon.
I'm on the calling from Ankara.
Go ahead.
Like, this rain that fell, just the water from the sock away, returning back from my own toilet, and everywhere was filled up, and we traced everywhere. We couldn't find the place. I even called my landlord, and now we went to someone's party. We don't know what there was a hole there that they traced down to the soccer way that was bringing the water. So I don't know how we're going to do that kind of thing. And Oga, your English is very, very too much, so please bring it down. Most people in the village will not hear you, I beg. Put it down small.
Ida, thank you very much for your thoughts. You want to respond to that?
I think one of the first things he said is that they seem to have traced a source.
Yeah.
So evidently there's an unauthorized source of water into the soakaway. I think the first thing to do there is to stop that, and then maybe if they now evacuate it, they might find that it doesn't repeat itself, because you don't want a soakaway that's taking in all the water from everywhere. If not, it's not going to be effective. So one good thing you said is that they seem to have found one of the potential sources. Obviously. So that's the most uncomfortable thing possible.
All right, Carl, I think, or Kayla. Kayla is on the line. Good afternoon, Kayla.
Hi, good afternoon. Can you hear me clearly?
Yes, loud and clear. Go ahead.
Okay, so very interesting conversation, and thank you for creating the awareness. Design principles for wet climate. We have a pending crisis, and we really don't know what we're doing. The speaker talked about Louisiana. The first world country, I think they're equipped more than we are to handle such crisis coming up. But we're not even capable to handle anything like a flood, a storm, but we keep doing things that will endanger our society when it comes to this wet climate. Everything I said is right, but my question, where I think we need to be talking about, is the role of government in all of this. Environmentalists have said everything they need to say. Architects are speaking, but it seems government is not listening, because all the construction going on, you'd wonder how many EIAs have been carried out for those things. He also mentioned building with the flooding, flooding modeling in mind. How many of our buildings, how many of our constructions actually take that into consideration? Let's look at Port Harcourt, look at Eastern Bypass, the LNG area. We went and fulfilled the area. What is the plan? Do you understand what I'm saying? So everything is just going on, but we're not even looking at the EIA aspect of all of this. We are blocking natural waterways of canals, of water bodies. What exactly is our plan?
All
So
right,
I think the government really needs to do something about this. I don't know what the speaker has to say about
Kayla,
this.
thank you so much.
But thank you very much.
Thank you very much for your concerns. We're out of time, so maybe you could, respond to that in final words, and also let's have your social media handles for other questions that people might have. They can obviously reach you directly.
I mean, she raised a very, very real, question about the larger picture. It's great to have projects, but how do those projects integrate with the existing landscape? That thing where we create roads which are now respecting the flood levels, but we now more or less maroon areas and communities. It's a challenge, and there must be solutions preferred. And yes, the person in the best position is government, but when government doesn't do the EIA process thoroughly or with all stakeholders, you have this problem. Second thing, I mean, we can discuss it later on another day or maybe on social media. My handles are at Bozimo on most of those platforms, at Bozimo. I can be reached there, and we can discuss further and put minds together, because each of us is affected. Maybe your house may not be, but when you're trying to get from point A to point B and the road in between is flooded, it'll affect you. So we are all stakeholders in making our environment collectively much better than it is right now.
Absolutely. Thank you so much, Architect Ebi, for your time. It's always a pleasure having conversations on Architect's World with you. Thank you so much.
Thank you. It's a pleasure and a privilege. Always. You have a wonderful day.
You too. On this note, we get to wrap the show up on the sunny side. At 3 o'clock, Rivers Today, right after Dio takes you on Hard Facts. But some information from Living Gospel Mission.